These notes are on factoring. So we're given either binomials or trinomials. You could even be given a polynomial with 4 terms or 5 or 6. But our job here is going to be to try to factor it, try to write it so that I have a multiplication problem essentially. So the first kind of factoring I'm going to do is not necessarily the kind that you're going to see very often in the module, but I want to be sure that we understand that the first step I always do when I'm factoring is to see if there is a common term. So one, check for a common factor. So in my first example, my common factor is a 4 and an x. I can divide 4x squared by x, and I can divide by 4x, and I can divide negative 20 by x by 4x. So I factor out a 4x, and I'm undoing a distribution problem, so I'm asking myself, well, what number times 4x gives me 4x squared? That would be x. And then what number times 4x squared gives me negative 20x, which is negative 5. Example 2. Again, example 2, the first thing I need to do is check to see if there's a common factor. And in this case, there isn't. Not all the terms have x, and the x squared term has a coefficient of 1, which dividing by 1 is trivial, so I'm not going to take care of that. So now I need to check for the double distribution pattern. So in our double distribution patterns, we had 2 parentheses. Actually, I'm going to leave a little more space here. And when I did my double distribution with parentheses, you'll remember that I had this step in here where I had my x squared and my plus 20, but that this portion here together equaled a positive 9x. So when I'm undoing this double distribution, I remember that in order to get this x squared term, that is this spot and this spot. So I'm going to ask myself, well, what 2 numbers multiplied together give me x squared? Well, that's x and x. I then also remember that my plus 20 comes from multiplying these 2 spots together. So I need numbers that multiply to be 20. Well, I have more than one option here. I have 1 and 20 make 20, 2 and 10, and 5 and 4. So it either could be that this is a 1 or this is a 20, or flipped, 20 or 1, 2, 10, or 10, 2, 5, 4, or 4, 5. So in order to check what I should put there, in some ways it's a process of trial and error. And in the problems that we're going to look at initially, the trial and error is a little more straightforward. So my trial and error is to say, well, what numbers here and here combine to make 9? So now I'm looking at the list of factors I made for my 20, and I'm saying, well, do any of these factors add or subtract to be 9? And we'll talk about that in a moment. So I'm looking at this. Well, adding or subtracting 1 and 20 does not give me 9. 2 and 10 gives me 12 or 8. That's not 9. 5 and 4, that gives me 9. And in order to get a positive 9, these both have to be positive. So I have a plus 5 and a plus 4, which gives me 5x and 4x. 5x plus 4x, which is indeed my 9x. So just to rewrite this a little cleaner, my answer is x plus 5 times x plus 4. Now, some of you may have noticed with this problem that really I'm asking myself here for 2 numbers that multiply to be 20 and add to be 9. Asking this question will not always work. And the times in which it won't work is when my coefficient in front of my x squared, or my a value, is not 1. For our initial problems here, they are 1. So I'm going to kind of do this process a little quicker, knowing that I can use this sort of shortcut thinking. So g of x equals x squared plus 20x plus 19. I know that the pattern here, because the a is 1, is going to be an x and an x in the first part of my parentheses. So I have x squared plus something plus 19. And there's my x and x. And then my factors of 19 are 1 and 19. So it's either going to be 1 and 19 or 19 and 1. And the question becomes, what can I add or subtract these to get a positive 20? And I can add them. So plus 1 and plus 19, which means that when I am double checking my work, I would have a plus 1x and a plus 9x. Which gives me my 20x in the center. Next example. Our next example, we're going to use the exact same process. 1, check to see if there's anything in common to be factored out. There isn't. 2, check for the double distribution pattern. So the double distribution pattern tells me that I'm looking for, because my a is 1, since a equals 1, I'm looking for 2 numbers that multiply to 10 and add to negative 7. So I'm going to list my factors of 10. I have 1 and 10 and 2 and 5. The question is, do any of these numbers add or subtract to be negative 7, excuse me. So 1 and 10, if they're the same sign, are going to give me 11, either positive or negative. Or if they're different signs, they're going to give me either a positive 9 or a negative 9. Well, I don't want either 11 or negative 11, or positive 9 or negative 9. I want negative 7. For 2 and 5, if the signs are the same, I'm going to get 7 or negative 7. So that's what I want. In order to get negative 7, though, my 2 and my 5 both have to be negative. So I've got x minus 5 and x minus 2. Oops, I forgot my g of x up here. Next example. In my next example, I no longer have my a being 1. So I go back to my checking here and I say to myself, can I factor anything out in common? And I can. Each of these terms is divisible by 2. So I have 2x times the quantity x squared minus 7x plus 10. And many of you will notice that I actually now have the exact same problem I just finished doing. My a is 1, so a equals 1 means I'm looking for 2 numbers that multiply to 10 and add to negative 7. So my factors of 10 are 1 and 10, 2 and 5. And the 2 numbers that add to be 7 are 2 and 5. But in order to get the negative, I need to have a negative 2 and a negative 5. X minus 5, x minus 2. I want to say something that I should have said in the previous problem, which is the factors of 10, a positive 10, will either both be positive or both be negative. So in some ways, I actually have 4 options here. I have 1 and 10, or negative 1 and negative 10. I have negative 2 and negative 5, or positive 2 and positive 5. But I don't like writing out all 4 options. It doubles my options. And so instead what I'll do is I'll just remind myself as I'm doing the problem. I'll keep in mind that these both could be negative. Both of these could be negative, or both of these could be negative. Okay, our next example. Our next example, we're back to the lovely place where a is a 1. So a equals 1. So I'm looking for 2 numbers that multiply to negative 20 and add to positive 8. So the first step I'm going to do is to write the factors of negative 20. So that's 1, 20, 2, 10, 5, 4. But since the 20 is negative, that means that one of each of these factors has to be negative. This actually is negative 1 and positive 20, or positive 1 and negative 20. Positive 2, negative 10, negative 2, positive 10, negative 5, positive 4, positive 5, negative 4. But again, I don't want to write out all of those options. I find that to be tedious. If you need to, that's totally fine. So instead, I'm really going to ask myself, well, what two numbers here subtract to be 8? Not 1 and 20, not 5 and 4, but 2 and 10. However, I need a positive 8. So now I'm in the land of, is this negative 2 and positive 10, or is it positive 2 and negative 10? Well, when I add a negative 2 and a positive 10, that gets me my positive 8. So I now can rewrite this as a multiplication problem. That is x plus 10 times the quantity x minus 2. Next example, g of x equals. So my a is 1 again. So I'm looking for two numbers that multiply to negative 3 and add to negative 2. So there are only two numbers, there's only one option for two numbers that multiply to be 3 or negative 3. It's my 1 and my 3. So the question is, can I place a negative sign on one of these such that I end up with negative 2? And the answer is yes, I can. If I make my 3 negative, I end up with negative 2 when I add 1 and negative 3. So I now have x minus 3 times the quantity x plus 1, and I have factored that problem. The next example. The next example looks complicated, but it actually is pretty much the same as what I've been doing. So my a is 1, which means I'm now looking for two numbers that multiply to negative 81 and add to, well, I don't have a b term. I don't have a minus or plus something x. And so what number represents nothing? 0. So in this case, in order for them to add to be 0, they must be the same number. They must be 4 and negative 4, or 5 and negative 5, or 1/2 and negative 1/2. So I'm asking myself, can I write 81 as a number times itself? And the answer is yes, I can. I can write that as 9 and 9. But in order to get it to be 0, one must be positive and one must be negative. My last two examples sort of are the place where now I no longer have a equaling 1. So a does not equal 1. So now I'm checking. Do they have a term in common? Can I divide each and every one of these by the same number? And I can't. 3, 2, and 5 are all prime, actually, so I can't divide them by anything. So now I kind of have to go back. I have to go back to that first method that we used, which is I have to recognize that the whole thing that I do when I do double distribution is that this number here and this number here in my parentheses have to equal 3x squared. Well, because 3 is prime, the only way to do that is to have a 3x and an x. I then know that my negative 5 comes about by multiplying the last numbers in each of the parentheses. So I know, and now I need to write my factors of 5, 1 and 5. Oh, only 1 and 5. But because this is a negative 5, I know that I have to have one of these be negative. So now I kind of do some trial and error here. And for that trial and error, I know I've been writing in pen, but I'm actually going to take out a pencil so that we can, actually I'm not. I'm going to write along the side here some of my trial and error work. So I know I have 3x and x in the beginning of both parentheses, and I can put a 1 or a 5. So now I do my middle part where I'm testing. I get a 1x and a 15x. If one of these were negative, would I get a positive 2x? No. I'd either get a positive 14 or a negative 14x. So this guess does not work. But I have a second guess I can make here. I don't have to have my 1 and 5 in these positions. I could have it be 5 and 1 because it still equals 5 when I multiply 5 times 1. So now again I'm doing my checking. So I end up with 5x and 3x. And if I make one of these negative, when I add them, do I end up with a positive 2x? And the answer is yes. So I know I have a 5 and a 1. I know I have my 5x and 3x. And since I want a positive 2, that means that my 3x must be negative, which means that my 1 must be negative. My next example, again, I'm going to check to see if they have a common factor. And in this case, the 5 and the 10 do, but not the negative 27. So I'm going to do this exact same process that I just did above. So I know that the only way to get 5x squared is for the first two terms in my parentheses to be 5x and x. I also know that in order to get my 10 as my last term in the trinomial, I need to have the second term in each of my parentheses multiply to be 10. I'm going to list those. That's 1 and 10, or 2 and 5. Again, put a little. In this case, my trial and error involves 4 options. Above it, the only options was 1 and 5 or 5 and 1. But in this problem, 5x and x, I could have 1 here and 10 here, or 10 here and 1 here, or 2 here and 5 here, or 5 here and 2 here. So there's a lot of options to try. As you get better at the guessing and checking here, the trial and error, you will find that you'll be much faster at this. So I can kind of do this in my head. So if I did this in my head and I put a 1 here and a 10 here, that gives me 50 and 1. 50 and 1 are not going to make 27. So I can knock that one off right away. I then would try, so that does not work. I then can try 10 and 1, but that gets me 10x and 5x. That's not negative 27. So now I know for sure that if this is factorable, this has to be 2 or 5 and then the other part of it. So if I I'm going to just try 2 and 5. And when I multiply, I end up with 2x and 25x. There's 27. But I don't want a positive 27. I want a negative. So that must mean that my negative 2x is negative and my negative 25x is negative. And put that in and do a last double check here. This gets me negative 2x and negative 25x, and lo and behold, that is negative 27x.